Hello, everyone. So we have another MathCON problem. So this was number 7 on the first practice on finals ebooks. Okay, so we have a 3 by 3 grid, which is right there. So okay, this is 3 units and this is 3 units, like in terms of the sideline, and we are looking for the number of squares of any size. Okay, so this is big deal that we can form by connecting 4 of the points. So we can kind of go ahead and like list them, maybe count them if we can like be careful really. So let's go with the first one, which is the obvious one. So one by one squares, right? So you can just say this is 1, right? This is 2, and this is 3. So if you just do this right here, so on the second row, we have 3, and then we have 3 more, so you can just see them if you want to. So if you just connect those, you know, it's not really perfect square, but you know what's going on. So these are gonna be all the squares that I can have with 1 by 1, okay? So that's the first type, but it doesn't have to be 1 by 1. So we do have 2 by 2s, right? So let's see how many of those do we have. So at this point, I highly recommend you to stop the video and just continue count and complete all the process and see what you get. But I assume you just did. So I'm gonna say this is 1, and if I slide this to the right by 1 unit, so that will be 2. Okay, and then if I go with these, which is 3, and if I go with these, that will be 4. So if I want to count 2 by 2, so that should be just 4 of them. And if I want to go with 3 by 3, which is just this guy, which is only one of them, right? So if I count them, it looks like 14, which is one of the choices. But you want to be careful because it says how many squares of any size can be formed. So it doesn't have to be just horizontal or vertically a square. So we need to find just squares by connecting some points, okay? So we saw the segments, like the sides were either horizontal or vertical of those cases, but we might have some other ones, like we could have this one as well. So in this case, the sides are vertical, right? I mean, sides are diagonals of basically these points. So you want to be careful with this. You know, this is one of them, and you can just move this to the right by 1 unit. So you will get another one like this. And if you move this one more time, so you will get something like this, but it will be off the grid. So which is why it doesn't work. And if you just slide this this one unit below, so you will get, I should use different color. So you will get something like this, which will be another one. And if you slide this to the right, and will be this one. So as you see, we have 4 of these. Okay, so let me write. But in this case, you know, what is the side? Like in the first one, I said 1 by 1, 2 by 2, which is okay. But in this case, what's this side, right? So if you are familiar with the Pythagorean, so maybe it's better to remind for those. So whenever you have a right triangle, okay, so any right triangle. Okay, so let's say this is A, this is B, this is C. In a right triangle, the side square, so some of the sides that is next to the 90 degrees, A squared plus B squared, is equal to square of the third side, which is opposite to the 90 degrees. That's called hypotenuse. And this is called Pythagorean theorem. So if you use, like, say, we don't have triangles, but we can make one if you want to. So let's say you connect these. So this is 1 unit, this is 1 unit. So since this point is just intersection of the vertical and horizontal, that has to be 90 degrees. If you use a Pythagorean in that triangle, so 1 squared plus 1 squared equals like c squared. So that will be 2 equals c squared, and take the square root. So c will be square root of 2, which means this segment right here is root 2. So that is root 2 by root 2. And then we had 4 of these. Okay, I just did extra work just to kind of make sure we are good with that. And then I just like to see how we can make sure everything is possible that is counted already, okay? So that is one of them that we could have. But think about another way to make a square from this square, right? So I could take this point and connect with this. I just move to the left by 1 unit and down 2 units. If I just do this one below and 2 right, so I will get this, and I can have this and this. So this is also a square, and then this, like this side is 2 units, this is 1 unit, so 2 squared is 4, 1 squared is 1. If you add 4, 1, which is 5, c squared will be 5, c will be root 5. So which means if you want to count the square, that is root 5 by root 5, so that is just, this is one of them, but we could have something else as well. So we can have this guy like this, right? So this is also another one we just kind of rotate a bit to get another way out the same size. And that is just, I guess, only 2. We cannot have anything more than that. So which is why that is gonna be 2. And I cannot have anything more than that. Like I cannot just go 1 by 3. Let's try this. So let's assume, okay, so let's assume we take this point and we move to the left by 1 unit, and then we want to just go 3 units lower, which will take us there. And if you want to get a square, so you just need to have like 3 units to the right, but 1 unit to the right, like right, 1 unit below and 3 units to the right, which will give us something like this. And if I want to do this, you see, it will off the grid. So which is why we cannot really have anything that is like this. The legs will be 1, 2, 3. So this is the largest we can have. So 9, 10, 14, 18, 20. So it looks like the answer is this guy. So it took a bit longer than what it has to be, but I hope that was clear. So if you need some practice about the Pythagorean, so it's good to do so as well. Okay. So that was the number 7.